High-performance engines typically incorporate a constant-speed propeller for greater efficiency. Engine RPM is controlled and changed by changing the pitch or the bite taken by the propeller. This is regulated by the propeller governor, which changes the pitch to maintain the RPM that you've selected. Propeller controls take one of two general forms, a lever or a vernier control. They both do the same thing. There's another addition. Because you have two things to use in controlling engine output, a throttle and a prop control, you need two instruments to keep up with what is going on. The propeller control affects the RPM gauge, or tachometer. The manifold pressure gauge is more directly controlled with the throttle. Push the throttle in or forward for more manifold pressure and more power. When the engine is at rest on the ground, the manifold pressure gauge displays the ambient atmospheric pressure. When the engine is running, it is an indication of the absolute pressure of the fuel and air mixture in the intake system of the airplane, or the intake manifold pressure. At full throttle, it will be slightly lower than the outside atmospheric pressure. Since atmospheric pressure decreases as you climb, less manifold pressure and in turn less power is available unless the engine is equipped with a turbocharger, which we will talk about in a few moments. You'll find on the pre-takeoff checklist instructions on how to cycle the propeller to make sure everything is working properly and the engine oil used to control the propeller is warm. Generally, you will run the engine up to a specified RPM, pull the prop control aft, and momentarily look and listen for a decrease in RPM as the prop control is pulled, and an increase when it is pushed back in. When the prop control is full forward, the propeller pitch, the bite it takes of the air, is low, and the RPM will be high. When the prop control is full back, the pitch of the prop increases. It takes an even bigger bite out of the air, and the RPM will be lower. High pitch, low RPM. Low pitch, high RPM. The advantage of this over a fixed pitch prop is in greater propeller efficiency over a wide speed range. For takeoff, the prop control is all the way forward, which gives you maximum RPM and allows the engine to develop as much power as possible when the throttle is fully advanced. The difference between a constant speed and the fixed pitch prop found on many trainers is evident here. The RPM on a Skyhawk, for example, at the beginning of a takeoff run will be about 2100 RPM and will increase as the airplane accelerates. With a constant speed prop, with the propeller control all the way forward, the RPM will go right up to the red line, usually somewhere between 2400 and 2700 RPM, depending on the airplane, and it will stay there. Once the airplane is up and, say, 500 feet above the ground, a power reduction might be called for by the checklist. While most engines may be operated at full throttle and maximum RPM on a continuous basis, be sure to read the limitations for word on this. Many offer a cruise climb procedure that gives a good balance between noise, forward speed, rate of climb, and economy. When it comes time to reduce power, the generally preferred way to do it is to reduce the manifold pressure first and then reduce the RPM. Likewise, if increasing power, increase the RPM first and then increase the manifold pressure. The reason for doing it this way might be related to a car with a manual shift. Going too slow in a high gear lugs the engine. Flying with a lot of power, but with the RPM quite low, may lug the engine of the airplane. When you reach your cruising altitude, select a manifold pressure RPM combination from the power chart. Maximum recommended cruise power is usually 75% of rated power, which, with a non-turbocharged engine, can be developed up to about 7,000 feet. You'll notice on the power chart that you also take temperature into account when setting the power. The colder it is, the less manifold pressure it will take to develop a given amount of power.